Hey there! Today we're going to talk about something you see literally every single day. Something so common we probably don't even think about it. Shadows. But it turns out there's a pretty amazing story hiding in those dark patches. A story of art, time, and even some mind-blowing planetary science.
I know, it sounds a little out there, right? Almost like science fiction. But that dark shape that follows you around on a sunny day, it actually holds the key to how we first told time, and how we figured out one of the biggest measurements in history. The Hubble shadow. It's way more powerful than you think.
All right, first things first, let's break down the actual recipe for a shadow. I mean, what is it really? And what do you need to make one? Turns out the recipe is super simple, but every single ingredient is absolutely essential.
So here's the simplest way to think about it. A shadow isn't actually a thing, it's the absence of a thing. It's an absence of light. Light travels in straight lines. So when something gets in the way, it just blocks that path, creating a little patch of darkness right behind it. And boom, that's your shadow.
Okay, so to get a really good, dark, crisp shadow, you need a certain kind of object. And the key property here is a word you probably know: opaque. Opaque materials are basically like a brick wall for light. They don't let any of it through, and that's what gives you those sharp, clear shadows we all recognize.
Let's just put these side by side. It makes it super clear. On one hand, you have something opaque, like a book or a wall. It blocks all the light, creating a nice, dark shadow. But on the other hand, you have something transparent, like a totally clean window. Light just zips right through it. No blockage, no shadow. Simple as that.
Okay, so we've got the how-to down. Now for the really fun part, controlling it. How do you actually change a shadow's shape and its size? This is where things get interesting, and where a shadow stops being just a science fact and becomes a tool for art and even for discovery.
And the wild thing is, a shadow is basically a perfect 2D copy of the object's outline. This is exactly why shadow puppets work so well, right? You can make your hand look like a dog or a bird just by playing with its shadow. And it's the same idea behind silhouettes, which capture the exact profile of a person.
So, shape, check. But what about the size? How do you make that shadow bunny on the wall go from being tiny, the size of your hand, to suddenly growing to cover the entire wall? Well, the secret isn't in the object itself. It's all about where you put it.
Is a super simple rule, but it's kind of the opposite of what you might guess. The closer you move an object to the light, the bigger its shadow gets. And the farther away you move it, the smaller the shadow becomes. So a shadow's size isn't fixed at all. It's this dynamic little dance between the object and the light.
All right, enough with flashlights and puppets. Let's scale things up. Like way, way up. We're going to swap out our little light source for the biggest one we've got in our solar system and see how these exact same rules play out on a massive planetary scale.
I mean, the sun is our planet's ultimate flashlight, right? And everything on the surface of the Earth, a stick, a building, you, me, we're all opaque objects just blocking that light. When you think about it, our whole world is basically a giant shadow-making machine.
And you know how the sun seems to travel across the sky every day? Well, as it does, our shadows go on this totally predictable journey. In the morning, when the sun is low in the east, our shadows are super long and they point west. Then, right around midday, when the sun is highest, our shadows get as short as they're going to be all day. And then, in the afternoon, they stretch out long again, but this time they're pointing east.
And that reliable pattern, that daily journey, that's it. That's how we first figured out how to tell time. A sundial is really just a clever device designed to track that exact movement. By marking where a shadow falls, our ancestors could measure the hours passing by, long before any mechanical clocks were even a thing.
So, shadows can tell time. That's already pretty impressive. But what if I told you that wasn't even the shadow's most amazing trick? They were also used to do something that sounds impossible: calculate the size of our entire planet. Let's dig into how on earth they pulled that off. And get this wasn't done with satellites or GPS or any of our modern gadgets. No, this incredible measurement was made more than 2,000 years ago. It's just an amazing testament to what you can figure out with just your brain and a little observation.
The person who pulled this off was an absolute genius, a Greek librarian named Eratosthenes. He was the head of the Great Library of Alexandria, and he used his understanding of light and shadows to do something that nobody had ever done before: measure the world.
Okay, his method was just brilliant. So he had heard about a city where on one particular day of the year, the sun was directly overhead at noon, so much so that it cast no shadow down a deep well.
But at that exact same time in his own city, Alexandria, which was hundreds of miles north, a stick in the ground did cast a shadow. And here's the mind-blowing part. Eratosthenes realized that the angle of that little shadow was the exact same as the angle between the two cities relative to the center of the Earth. So by measuring that simple shadow, he figured out the planet's curve. He used that angle, plus the distance between the two cities, and calculated the total circumference of the Earth with stunning accuracy.
So think about that. Just a tiny difference in a shadow's angle between two places. That was the key. That simple observation was enough to unlock the true size of our entire world. It's got to be one of the most brilliant moments in the history of science, all thanks to a shadow.
It's just amazing, isn't it? From telling time to measuring a planet, the Hubble shadow reminds us that some of the biggest discoveries can be found in the most ordinary, everyday things. It really makes you wonder, right? What other giant secrets about our universe are hiding out there in plain sight, just waiting for us to look at them in a slightly different way?